Hello everyone. I know it's been a long day for a lot of you, so I'm really thankful for sticking around and for willing to listen to my talk. My name is Jakub. I'm a QA consultant with Cyber Alpaca. I guess that most of you have not heard about us before. But for many years, we had this pleasure of working very closely with Squish and with people behind Squish Success. If you are not familiar with Squish, this is a really great GUI testing tool. And there are awesome, cute people at this event that can tell you more about it. But for us, it gave us opportunity to work with different teams and companies around the globe, in Americas, in Europe, and Asia, and support them with their test automation, especially GUI testing. And no matter what company that was, no matter what industry that was, all of these companies, they wanted to have a really robust, reliable GUI test. But what does it mean, GUI testing? And I noticed that for many companies, this means something different. There are some common parts and there are some differences. And my laptop died. Okay. Okay. But is it really so important to that all of us have the same understanding about GUI testing and the scope of this testing? I would say not necessarily, as long as within our team it is well defined and we are aware of its scope and its limitations. But from my experience, QA engineers, when they say GUI testing, they mean functional feature testing. So they want to verify if the feature behind GUI really works, not necessarily how the GUI looks like. And this may cause some really amusing bugs. And I would like to show you some examples today. Yeah. So this is the Alpaca tracker application. Really feature-rich application with amazing GUI, as you can see, and think about it as a friendly animal monitoring tool, where you can register your alpaca, where you can watch it later on cameras, where you can read daily updates about its health, mood, maybe some beefs with neighbors, llamas, things like that. And because this GUI is so complex and there are so many features and we need so many tests to keep the quality high, some smart people at our company decided that we should implement GUI tests, and that's first good move. Right. But again, if we think then what this GUI testing is, then maybe we should look at the ISTQB definition. And it says, testing performed by interacting with the software under test via graphical user interface, which may mean a lot and also not so much. In practice, each team I worked with interpreted this a bit differently. But the common part was that the testers, QA engineers, or developers expected that our tests are going to simulate end-user interactions with the application. And simulating that with tools like Squish is relatively simple. So clicks, drags and drops, typing text in. What is really difficult is to simulate the human perception of the application. So when we see a bug as humans, we see that something is off with the application. It's really easy to say, there is something wrong here. But for our test, they need to know what we really expect from the application. So let's think about preparing a feature file, something that would define some test scenarios for our application. For this demo purpose, I decided to use Gherkin syntax, but it really doesn't matter what test development methodology you use. The ideas I want to share with you should apply to all of them, I guess. Right. So first, I decided that I want to tackle a feature of registering Alpaca. So for this feature, I can define multiple different scenarios, like successful registration, aborting registration, or registering multiple alpacas at once. The first one could look like this: successful registration. Given Alpaca tracker is running, that's our application, user opens Alpaca registration dialog, right? And this is done by, I could just show you. Can I do it? Oh, is it going to work? Nope, sorry. By clicking this plus button, I hope you can see it here, right? This should open the dialog. And then we provide Alpaca name. We confirm our registration by interacting with the register button. And after that, we should see additional Alpaca on top of the list. So once the scenario is defined, we implement the logic behind it. We write some code. It can be, I don't know, Python script, let's say. We run it. All tests are passing. Everything is green. We get nice report. We push it to production. Customers or users are happy. And then a month or weeks later, we get a bug report from our user saying that something is off. And because this bug was caused by some change in the, let's say, GUI structure that is not related to this feature. And this bug may look like this. So our buttons, instead of being placed below the input field, are placed on top of it. But because the input field is still accessible, the feature behind it works, right? Or something like that. Right? Someone may not consider this as a bug if it's a new user, right? But if it's an existing user, that's it might feel a bit off. Or like this, right? So one button on top of the other. But these bugs may not be related even to the dialog. This may be misaligned, a list of alpacas, maybe the paddings are off or margins are off, or the description overflows the container of the, like, where it should belong. Right? The thing is that our scenario that we defined is still passing. So we received this bug, and we know it's related to our feature, but when we look at the test reports, everything is still green. And to be honest, that's not necessarily bad. For all of these cases, as long as these UI elements we interact with are accessible, our report will remain green. And that's fine, because we probably don't want to rewrite and update our test scenarios every time we decide to move button to the left, or change the order of the buttons, or change margins. Right? Sorry. Maybe one more thing. None of the bugs I showed you, none of them are really catastrophic. They're not breaking bugs, feature is still working. The important part is there. However, the user may consider if we tested our application at all. Right? It may impact the trust we built over the years. Okay. So now the thing, how I would define feature testing. It's checking if software functions as specified, which is a really broad definition. Because it may include not only GUI tests, but also performance or some backend tests. And on the other side, we have GUI tests, which very often are the same, but they are like almost the same, but we test our application through graphical user interface. The main difference between feature and GUI testing in this case is the primary concern of our test. If we are testing the GUI or if we are testing the feature behind it. In practice, they overlap so much that we can use one on the other definition. So what does our scenario really very check? Like, it checks if the dialog can be opened and if it's accessible. It checks if the input field is present and we can type text in. It checks if all the buttons we interact with respond correctly. We verify this registering functionality. We verify navigation flow. We verify GUI elements responsiveness. What we do not verify is the layout of the application. How does it really look like? So if the elements are positioned correctly, if they have proper size, if they are rendered as expected. So it's almost like it's irony of GUI tests that they are very often they don't tackle just GUI. They tackle the feature behind the GUI. Right, but again, these are really coupled together, and it's really easy to miss these visual aspects of testing the application. So if we miss our visual verifications, that opens a gap in our testing process, in our testing coverage. And this gap might be, for example, layout testing. So most teams I worked with skip this layout testing and they focus only on testing features, because layout can change every day, right? And the feature remains the same. The feature should still work. Right. But still, it may, as I told you, it may hurt the confidence our users had in our product. But we can fill this gap with a little bit of extra effort. Okay. So now I would like to show you 3 approaches that you may use to do that, to improve your test coverage and to rebuild this balance that is mentioned in the title of this presentation. First approach would be to extend already defined steps of our tests. That means for actions like when user opens Alpaca registration dialog, before this change, we just click the plus button. But after that, we could add the visual verification that verifies that the verified dialog layout looks as expected. For the action end user confirms, I made a mistake, and I realized that today, actually, the order of these steps should be different. So first, we should verify if the button looks as expected, and then we interact with the button, as clicking the register button closes the dialog, right? So after we close the dialog, it's no longer possible to verify if it looks all right. The benefit of such solution is that we don't need to modify our tests. The downside of this solution is that we are hiding checks in our test framework. So by looking at the test cases, we are not sure what is verified inside. It also leads to redundant verifications. So if we use a test like user opens Alpaca registration dialog a lot, it means that every time we will perform this extra verification, which might be unnecessary. It will extend time execution, it will extend resource consumption, it will make our test reports longer and harder to understand. The next approach might look like this. So instead of hiding our verifications inside the steps we already have, we add extra steps to our already existing test cases. So after opening the registration dialog, we verify if the dialog looks as expected. This verification is visible in our test scenario right away. We know which parts of the application and which verifications are covered in our test scenario. However, this leads to mixing test concerns. Our single feature test, our single scenario is going to verify both functionality and layout. And if we implement fail fast methodology, it may extend the time that we need to discover some bugs. Let's say at the same time we have bugs in layout and in functionality. In this case, until we fix the first step, so the actions related or application where we open the dialog, we won't see the results of the visual verification. On the other hand, like the pro of this solution would be that verifications are performed on demand, so there will be no redundant verifications. The third approach, and the one that I do recommend, is creating dedicated scenarios that will focus purely on verifying layouts and visual aspects of your application. So this type of scenarios should keep the interactions with the application at minimum. We should not trigger any extra features of the application. We should not interact with nothing. We should not interact with elements that are not crucial for this particular test. This scenario may look like this. So when the application is running, user opens the registration dialog. Then we verify if the dialog looks as expected. So we verify layout. And then we verify if all visible text are not truncated, if they are displayed correctly. So again, our verifications are visible right away. We know which test focuses on feature, on functionality, which test is focusing on layout checks. Our tests have just a single responsibility, which usually is good. However, it leads to longer execution times, and we need to put some initial effort to create such tests. And it may not sound really innovative, right? Creating such tests, but you would be surprised how many teams do not consider testing layouts at all. Testing layouts when they are testing, when they're doing GUI tests, right? GUI tests is mostly about checking the feature behind it, but not how the application really looks like. And the reason behind that may be that image-based testing does not get a really good press. It's unreliable. Verifications take a long time. We need to update them a lot. However, if we use these image verifications or layout verifications, however we prepare them in dedicated tests, it may reduce this maintenance cost and still bring us a lot of benefits. Okay. Now I would like to show you how some of these verifications can be implemented with tools like Squish. Right. I will not go into details. I would just like to share with you the features I find useful for different cases of layout verifications. So the first one is image verification point. With this one, with the single line test.imagePresent, we can verify if a certain image is displayed anywhere on the screen or in certain area of the screen or even in the place where the object exists. This image can be a PNG file that or a screenshot we take with any tool that we want to. I would just recommend cutting off all the dynamic elements, text, maybe animations, things that are constantly moving and that are possible cause for the instability of our tests or flakiness in our tests. These kind of verifications are really easy to review, right? You just need to open a PNG file and see what is verified there. But they require updating these images often. To be honest, it really depends on the if your application is in the maintenance or early development phase. Alternative way of verifying our layouts is using screenshot verification points. These are like our screenshot verification points are basically XML files that stores information about the image that we expect, the comparison mode that we want to use, and the masks that we applied to our verification. So instead of editing the screenshot that we took here, we can just draw a rectangle around the areas we want to exclude from the verification. These masks are flexible. We can resize them, we can add them, remove them, move them around. Like the downside of this verification is that without a proper tool that comes with Squish, we cannot easily look inside. We cannot easily see what is verified there. Right. And the third way is to use Squish visual verification points. I know that the naming might be quite confusing. We have image verification point, screenshot verification point, and visual verification point. But this one is really powerful, and I used to say that with this power comes great responsibility, but this phrase was used this morning and during other presentations, so I cannot do that anymore. What it can basically do, it grabs the object reference. We activate like verification point creator. Then we point the object we want to verify. Squish will take a snapshot of these objects and all children elements of this element, like here, the children elements of our dialog. So the visual verification point is going to verify the structure of these elements, some of their properties, geometry, size, and position, but also screenshots. On top of that, we can apply masks or exclude certain elements from the verification. So again, it's really flexible, really powerful, but there is, behind this verification, there is yet even larger XML file that might be hard to maintain. Also, if we accidentally, let's say, uncheck a certain verification, we will not see that in our test script, right? So it might be that if we forget to activate some checks, we may never verify, let's say, geometry of a certain object, and we will not see failures in our test reports. Right. There is one more thing I wanted to talk about. This is the text truncation verification. This is the topic that is raised and was raised by many teams I worked with, especially when our applications support multiple languages and some words are really long. There are different ways you can verify that. If you go to Squish knowledge base, there is article about that, one or two. If you go to quality assurance, Qt quality assurance blog, there are more articles about that. But there is also another approach that uses OCR-based verifications, so optical character recognition engines, like Tesseract. With this approach, the general idea is to grab all the visible elements like labels, texts, anything that we can read, basically, and then iterate over this object. And for every object, we grab the text property, use it as an input for the OCR engine, and then we ask the engine to check if this text is displayed in the place where it should be displayed. If the text is truncated, we will get failure. If the text is covered by other element, we would also get a failure. Okay. All right. So to sum it up, my experience says that GUI testing often focus more on features than the GUI itself. Layout testing is crucial, but it's overlooked very often. By understanding the differences between GUI testing and layout testing and feature testing, we can find all the gaps, or maybe not all, but a lot of gaps that we introduce and try to patch them. And sometimes missing these few tests and having these few bugs will not sync our product. Like years ago, there was a bug in Chrome browser that if you opened a lot of tabs, they overlapped even the minimize, maximize, and close button of the window, so they were unusable anymore. In Windows 8, there was a bug that under certain conditions, the notifications that we got were styled like in Windows XP, which was probably not desired. And in Outlook, in some older versions, there were glitches and problems with ribbon menus when we used high DPI scaling. Right? But these applications are still with us. However, if I would work, or maybe if I would be a patient undergoing a serious surgery, I would probably not like to be kept alive by the application that displays my life parameters incorrectly, or that where they are covered by some other elements or displayed in the wrong place. So let's make sure that we really test what matters, both function and form, because sometimes the way the application looks like is as important as the way the application behaves. Thank you for your time. If you would like to find me, contact me. You can find me at jakub.topolski.cyberalpaca.com, at our website, or cruising around during the after presentations part. Thanks.